Welcome to this Mobile World Live webinar on the topic of the first private 5G network in Taiwan enables Industry 4.0, sponsored by ASOCS and Affirm Networks. Thanks for joining us. My name is Joseph Waring. I'm the Asia editor for Mobile World Live. I'm based in Hong Kong, and I'll be moderating this session. Industry 4.0 is one of the hottest topics in the supply chain world. This digital revolution is a combination of the industrial Internet of Things, artificial intelligence, machine learning, advanced analytics, and cloud computing, to mention some of its pillars. However, it can be intimidating and challenging for companies to build their Industry 4.0 path, find economic justification, and fully understand how to leverage the functionalities available to them. This webinar takes a close look at how Inventec, a leading manufacturer in Taiwan, is enabling Industry 4.0 through smart manufacturing using private 5G networks. You'll hear how these networks are expected to be a key enabler for the factory of the future vision, delivering high capacity, low latency, support for massive numbers of devices, and IT-like flexibility. Inventec is an early adopter and recently deployed Taiwan's first private 5G network to be used in an active Industry 4.0 production line, enabling the many benefits of smart manufacturing, such as reducing costs and improving yields. To start things off, we're going to play a video for an overview of what the network deployment enables.
Incorporated in 1975, Inventec has evolved from a manufacturer of calculators and telephones to a leading original design manufacturer of laptops, servers, and wireless communication products. In the 5G era, Inventec is expanding its horizon to 5G private network and system integration, transforming its own world-class manufacturing sites to 5G smart factories. 5G features low latency, high mobile speed, and massive machine communications, bringing life to innovations in industrial automation, human-robot collaboration, and manufacturing process control. Inventec has integrated the emerging software virtualization technology and open hardware concept with x86 standardized servers, building the world's first fully virtualized, Open RAN-based standalone 5G enterprise private network. The network provides unprecedented reliable connectivity required for IoT applications, with top-notch capability and security as first-tier global telecom carriers can offer. Enabled by 5G, automated guided vehicles that handle raw materials and finished products in the factory can now be seamlessly linked and tracked without being restricted by Wi-Fi's latency in large-scale movements. Having a secure network that supports a vast number of connections, it is now feasible to rapidly deploy and adjust production lines, reducing machine idle time. Whether it's mass production or small batch, 5G network can significantly reduce false alarm rates of auto-optical inspection and improve overall production efficiency. Inventec's 5G AI of Things end-to-end solution includes the core and radio access network, as well as the customer premises equipment, and a series of highly scalable multi-access edge computing servers. Inventec's E850G4 server can not only be configured with front-haul FPGA and smart NIC cards to run on ORAN networks, but also with acceleration cards and deep learning frameworks to be applied for AI inferences and training models. It can be further integrated with Big Data Manufacturing Cloud to fully utilize the power of AI of Things. At AOI stations, high-definition 2 and 3D scanned images are transmitted to AI analysis systems through 5G to identify component misplacement and defects. The analyzed data are feedbacked into re-inspection stations for real-time reviews. As a result, increasing auto inspection accuracy to over 90%, improving SMT first pass yield to over 85%, and reducing re-inspection labor force by 50%, significantly upgrading the manufacturing capability. Continuing to implement intelligent manufacturing systems, including applications of artificial intelligence, AGV, AMR, equipment monitoring, cybersecurity deployment, AR, VR, and digital twin. Inventec's 5G Smart Factory will drive smart manufacturing to the next generation.
That sets things up nicely for us to start the panel. To discuss this topic, I'm joined by three executives involved in planning, managing, and deploying the build-out. Today, we have Albert Chen, Senior Vice President at Inventec, Ashwin Moraganti, Chief Product Officer at Affirm Networks, and Gilad Garan, CEO of ASOCS. Welcome. It's great to have you all here. Before we dive into the panel discussion, I want to ask Albert to give us some background on Inventec's operations.
Thank you for inviting me to join this webinar. Inventec Corporations was founded in 1975. Currently, our revenue is $16.2 billion US dollars. We have a global employee over 36,000. Now, let me introduce a little bit on our products. We are producing 100 million devices per year. All the devices include 4 million of cloud infrastructure, 21 million of computing devices, and 75 million of smart devices. We are proud that we shipped 25% of servers worldwide. And our headquarters now is located in Taiwan, Shilin. We have many manufacturing sites that are located in Shanghai, Nanjing, and Chongqing in China. We also have a factory in Czech and Mexico. We also now are adding more sites in South Asia and also some in Taiwan due to the recent US trade war.
Many thanks, Albert. So now we're going to get started by looking at what these companies have implemented in Taiwan. First, I want to let the audience know that you can submit questions at any point during this session. Look for the attendee question box below the slides and just type in your query. I want to start the questioning with Ashwin. What was Affirm Networks' role in Inventec's deployment, and how did you help the company overcome critical problems around managing its own private 5G network, such as managing connectivity, services, and operations?
Thank you for having me. Inventec came to us, they wanted to introduce 5G to reap the benefits of this high bandwidth connectivity and low latency. They wanted to transfer high definition scanned images to AI-based image analysis systems. They wanted to essentially implement 5G and AI to improve automatic optical inspection technology in the production lines. And they wanted to expand further on 5G for other use cases with AR, VR, and AGV vehicles. The private networks, essentially what they wanted, allows them to integrate diverse sensors, machines, people, vehicles across a wide range of applications and usage scenarios. And with this private networks, they're able to get secure, private, reduce latency, reduce backhaul costs, and extremely lower managed costs. So Affirm provided a virtualized cloud-native 5G core. It includes all new network functions like AMF, SMF, UPF, NRF, and AUSF. And that is built on open technology platforms. And we delivered a multi-vendor solution to achieve Inventec's vision. We partnered with ASOCS for Open RAN, HPE for 5G subscriber management solution, an entire new UE ecosystem, and delivered really a first of its kind 5G private networks. Back to you, Rick.
Great, thanks. Gilad, I want to ask you the same question. What did ASOCS provide, and how are you helping Inventec, overcome some obstacles?
Sure. So, as Ashwin has already clearly described, we had to solve many world first challenges within this project. So, if you zoom out for a second about what it is we had to build here, is that first and foremost, of course, we had to deal with the actual implementation of the 5G standalone protocol. Then we needed to run this as software on Inventec's own IT hardware. Then we needed to build all this pretty much in remote mode, although we did have an integrator on the ground. And fourth, we had to, kind of chain all these multiple vendors and multiple functions into one coherent system that at the end of the day needed to work in an industrial floor. So, it is a completely different mindset than the traditional send me the equipment in a box, let's bring it up and see that it all works. Rather, this was a multi-layered project in which we had to build IT infrastructure, then bring in the individual components of the software, and then make it all work into one orchestrated solution. So, looking a little bit in hindsight, I think it was quite bold a move by Inventec and all of us to embark on this project. But the good news is that we've managed to pull it off. And what we have learned from this is that a multi-vendor approach actually works in your benefit in this type of a project, because each one of the partners could bring in his viewpoint, but also his know-how into creating this kind of a solution. So I think what it built very well was to address Albert and Inventec's great vision about not just building a 5G standalone network, but actually building in pure IT running on top of their platform.
But yeah, I want to bring in Albert. And can you share what use cases Inventec implemented and what are the results so far?
Before I share our use cases in this ORAN project, I would like to share the manufacturing platform with this 5G ORAN. From the picture, you can see we have a great partners from ASOCS to provide 5G RAN, including CU, central unit, distributed unit, and radio unit. A firm network to provide our 5G core. On top of that, we have Waving company to work with us in Taiwan. This leads us to accomplish this first 5G SA core in Inventec, especially in Taiwan. Our first use cases is to apply to AI, AOI system, automatic object inspection. We can send those failure pictures in our PCB assembly line through the 5G link to our server. And the server will do the training part. After that, we can send inference back to edge server. By doing this, we now can achieve increasing first pass yield rate and reduce 50% of human inspect manpower per assembly line. Definitely, we are preparing more applications when moving forward. Maybe I can take more time later on to share with you.
Okay. Well, I want to stick with you, Albert, and look at sort of the hows and whys behind it. And what were Inventec's business drivers, and goals launching a private 5G network? Why do you decide to take this route?
Currently, as you know, we are facing a global challenges in our manufacturing. As you know, after the U.S. trade war, that really makes us think the way we do manufacturing. Now, we need to face a lot of challenges, include globalizations, sustainability, demographics, urbanizations, threats to global stability, accelerating product life cycle. Furthermore, we need to change our customer habits and in external industrial policy trends. We need to be more distributed manufacturing so that we can reduce the risk. We also like to rapidly respond manufacturing side due to the many creative IoT products coming. Sometimes we are facing customized manufacturing. We need to deliver quick, and on top of that, we also need to be innovative to do our products. Therefore, based on aforementioned items, that means that Inventec now needs digital transformation in our manufacturing side. We'd like to create value through innovations, strengthen our core competitiveness, and reduce production cost, improve quality, and grasp market. Then, how do we do digital transformation? The first thing to come to our mind is we like to build a so-called 5G superhighway in our factory. Then we really can apply with those 5G features, such as eMBB, enhanced mobile broadband, URLLC, ultra reliable low latency communication, and finally, massive machine type communication. Then we believe with these 5G can really bring us to the next stage.
Right. So I want to go back to Ashwin and ask you, what were the main challenges on the mobile core side that made the industrial use case unique, and what were your main challenges there?
Yeah, thanks, Joseph. This is very different than an LTE, and it's not really yet a mainstream technology. 5G is a completely service-based architecture, API-driven, and a lot of new 3GPP-defined protocols. It's essentially a cutting-edge technology that Affirmed has been primarily working with Tier 1 mobile operators to deploy the world's first cloud-native 5G cores. But we recognize the power of 5G and what it is called in the standards world like non-public networks. And we've been able to package the same carrier-grade technology to address the needs of the new entrants like Inventec, who want to deploy and modernize industry automation with private networks. So when you're bringing together multiple vendors and deal with interoperability issues, and we ensure the end-to-end automation use cases flawlessly is a big achievement. And we also needed to have, a flexible architecture to deploy this. There are several components. We had to accommodate all components of the core to be deployed in the factory location, or we needed sometimes the ability to, deploy like a distributed technology using cups to deploy the user plane on the premise and the 5G control plane on the cloud. And this allows you to do like simplified multi-site deployments. Imagine a factory or a company having 100 sites, and you could be deploying the control plane on the cloud and just have the user plane provide the private network connectivity in the factory. We also, have to architect it for seamless roaming between sites, and also thought about, the ability to roam between these private networks and public networks. And we had to deliver a solution that was simple to deploy and operate and make it comparable to the ease of almost like Wi-Fi deployment. And that's, the biggest challenges that we had to achieve. And we successfully, delivered something with that. Thanks to, the innovations from ASOCS, ORAN technology, HPE's subscriber management system, and we had a very good working relationship to make it happen.
It seems like quite the orchestration.
Yeah.
So I want to bring Gilad back in and ask him what were the key elements in this project that made the industrial use case unique, and what were the main challenges that you faced?
Yes, so I think Ashwin has made a very good point. In fact, it sounds obvious, but it actually puts in a nutshell a lot of the challenges. The fact that we are building a relatively small scale, highly specialized network in a premise of a factory does not really relieve us from all the burdens of building a whole 5G cellular network. And once you realize that you still need to deal with the classical challenges of building a cellular network, starting with the basic features of RF planning, the specific noisy environment of all these machines running in a factory, all the stuff that people tend not to talk about, but still needs to be dealt with, regardless of the relatively small scale of that kind of a network. And we had to kind of learn how to address these challenges as we went along. And what we have done is we have sped up some of the developments that we had in AI, and I know that term is sometimes used too much, but in this kind of an environment, when you are in remote and you're dealing, you're not on-prem, the use of AI algorithms to create better planning, better network calibration had to come into play, and they would be very useful moving forward. The next key challenge that we were facing is that, well, it is similar to a macro network. In a macro network, you have so many different players, each one in charge of a certain optimization. In this project, again, although it's a relatively small scale project, the optimization that had to be done from the machine itself, through the CPE that was connected to it, through the RAM, through the Affirm core, to the application and back, actually create unprecedented challenges in the way you need to optimize these bits. And, to be fair, a factory owner or an application owner is probably much less tolerant than a consumer is in a commercial network. So we had to, from day one, we had to think about every single bit of latency and in this system, and we had to take that latency out of the system in order to create something that met expectations. And the third, I think we dealt with it already in my previous answer, but when I look at it, the fact that all of this can be done and provisioned in remote is an incredible asset to the multi-vendor and software-based approach, because I'm trying to kind of envision how could you really integrate individual boxes in a production floor at this scale and speed, and I think that would run into challenges that would probably even cause such a project to fail. So the fact that we had the software agility and we could harness standard IT tools into this integration proved eventually to be not a disadvantage, but on the contrary, a major advantage because we could have multiple development groups from a firm and ourselves and others log into the system, look at the individual problems that the data path or the control path had, and solve them in remote. And that is a very unusual exercise for sure in the RAN world.
Mm-hmm. Yeah, the integration challenges seem daunting. I want to take a look at what's next in this project and move over to Ashwin and ask, naturally these private networks are closely tied to edge computing and edge automation applications like AI, machine learning, AR, VR, etc. What is Affirmed and Microsoft's vision on this?
Even in this deployment that we have done with Inventec, you can see that the image analysis was part of it, and it was part of the automation that to energize the factories. And so edge applications are intricately tied with the private networks. And so there is an opportunity to actually integrate the edge applications with the private networks even more, and you can derive a lot more advantages. Like for example, instead of using GPS technologies for the presence, the RAN, the RIC can provide centimeter or millimeter level information. So the applications can actually derive the network information, and the applications can also talk to the network to enforce policy, and how the network should be treating different types of applications. There is a little bit of synergy that can be deployed. What Microsoft and a firm are together doing is actually, building together an ecosystem. We want to build together a private edge solution that can combine both the networks and the applications and bring this end-to-end intelligence through AI and ML. And more to that, we want to bring the developer ecosystem to the table. These applications are not just for factory automation. There are a lot of places like facial recognition technologies can be employed in retail scenarios for fast customer checkouts and various applications. So we want to bring together multiple applications, these edge applications, and so that folks like Inventec can actually combine the network plus the edge applications and go after multiple manufacturing scenarios or retail scenarios or security, these scenarios. So there is a lot of value that needs to be still extracted from the solutions, and that's what we are looking forward to, get to the next steps.
I guess that shows how flexible the platform is.
Yes, that's right.
So Albert, I want to ask you about what are the next steps from Inventec's perspective.
As we have successful to deploy AR AOI application in our smart factory, together within ASOCS and Affirmed network. The next step is that we like to deploy more and more applications in our factory. As Ashwin mentioned previously, that the next step for the edge deployment, which will combine network and applications. Also, ASOCS Gillette talked about the challenges of you need to do cell planning in the factory and multi-vendor RAN, or even timing in many low latency communications. This really match all applications that we like to do next, such as AGV, automatic guided vehicle, AR/VR, man-machine collaborations in the factory, and finally, digital twin. In the long run, we like to apply all these 5G network into our digital transformations in Inventec. We wish that we can communicate with our customers seamlessly to deliver good products and communication well.
All right, thank you, Albert. For the final section here, I'd like to take a step back and look at the bigger picture. Where is this market going? Lately, there's been a lot of talk about the future of 5G, and it's not living up to expectations. What do you think about this, based on your experience with this implementation? I think let's start with Gilad.
Yes, thank you. So I think, with the velocity of the modern world, I guess we should not talk about patience. So let's just first talk about where is this potential frustration coming from. It's mainly coming from the consumer market. And, when it comes to consumer expectations, I guess it's in the world of marketeers. But clearly in the consumer space, the expectation that 5G, this tremendous speed that it represents, would affect our daily lives is still far and remote. But if you look at the implementation of 5G in the enterprise world, and more notably in the use case such as the industrial world, I fail to understand where that frustration coming from. In fact, we're really just now starting to get away from the basic build of, let's call it the speed and the link, and starting to look at the auxiliary technologies which would make 5G in the use case such as industry successful. And as Ashwin has briefly mentioned, the combination of adding the data with its proper location, coupled with machine learning, would create has already created great benefits in this project, but it's really just getting started. So my advice to the ones who are slightly cynical about the new technology is wait, because what we're seeing now is really companies such as ourselves, with pioneering customers such as Inventec, starting to explore the benefits of combining multiple technologies in one. And that takes a little bit of time until everybody figures out the benefits. But once these underlying services, which are the link itself, the low latency services that it can bring, the location, and then connecting it all into these various services, I actually believe that the next year or two would be years that we would be focusing, and people would be very excited about that use case. In terms of the consumer world, that may be a topic for another webinar. The consumer poses other challenges and will definitely take a much longer period to prove the benefits of 5G.
Yeah, thank you for that insight. Before I ask the next question, I want to remind the audience that to submit your questions. We've had a few come in, but we certainly will have time for more. So please keep sending in your questions so we can give our panelists some challenging queries. Albert, I want to sort of that last question about the future of 5G and it's under expectations. I want to throw that question to you.
I myself, I'm a little bit more optimistic on the 5G deployment. The reasons are, as you know, 3GPP standards release 16 is frozen earlier this year, 2020. Release 17 with low latency and massive IoT are still ongoing. We all know 5G is different from 4G. That is due to 5G added more features in the network, especially the network slicing. That means that there are more services will be in 5G. All the services are deployed in 5G, maybe for the first time. And also 5G applications, as Gilad's slide mentioned previously, location-based data, low latency services, or even time-sensitive networks, securities. These are really challenges when deployed in the real world. On another side, let's look at IDC. Expects 5G connections will grow from 13.6 million into 1.8 billion in 2024. Therefore, we should be optimistic on this deployment. Currently, there are 15 5G-based strategic industry waiting to move into another milestone with opportunities, but definitely with lots of challenges. Therefore, the challenges on our 5G network in our factory include security issues, industry 5G chipset, time-sensitive network, AI analytic, and finally, it always a cost. That's why we need to be more patient to develop these 5G applications.
Oh, thank you. Ashwin, what's your view on that? Do you think 5G is underperforming?
Yeah, no, I think 5G is not underperforming naturally. I think it is the expectations which we need to get adjusted to. For consumer expectations, people are expecting faster downloads, like, download a whole movie in a couple of seconds. Those are going to be clearly visible, and that's about the kind of benefits that people are looking for. And for that, people are actually waiting for the devices to show up, like the Apple iPhones and the Android phones and stuff. So from the most other important aspects is really where the machine-to-machine communications, they are going to see the bigger impact. Now, we have seen factories where folks were trying to increase automation with robots, and we saw that the robots were actually non-working. They were not working because Wi-Fi and LTE was actually not working out for them. And so those are the scenarios where you will see the immediate benefits of 5G. I think Inventec's case and point is there that this is where 5G will shine. So we do feel that there is going to be a premium of 5G value in situations where machine-to-machine communications are there.
So I want to move on to the next question, and this is for Albert. When it comes to best practices and tried and tested cases are always a good source. What would you recommend for enterprises that want to improve supply chain performance and embrace digital transformation through Industry 4.0 principles?
This really is good question, also huge questions to answer. I will try to a few points for this. The spirit of global smart manufacturing for us is not just performing the automation in the factory, but interaction between manufacturer and customers, so as supply chain. Therefore, we like to focus on the entire value chain. It's connected in two-way communication without any delay in error, which improves efficiency and flexibility. Furthermore, reduce cost. Our main goal for our customers and our supply chain, that is the key. Then, if we are talking about enterprises, if you want to embrace digital transformation through Industry 4.0 in general, I will think about once you build 5G superhighway for these digital transformations, you need to think about AI in Industry 4.0 system. And you need to fulfill 5S principles, namely systematic, speed, streamlining, standards, and sustainable. After that, you develop the industry internet to make for more connected equipment and your customer and services through this value chain. So maybe just to build infrastructure and bridges with supply chain, then deploy the applications one by one. Hopefully, this can give us communicate well with all our supply chain or customer effectively. That's my little 5 cents feedback.
Thanks a lot. Moving on to some other questions. One question asked, we're trying to get our head around where to start with 5G. What do you recommend? Gilad, can you address that one?
So, admittedly, getting started with 5G can be daunting. Apart from the difficulty to understand all the technical terms and of this new technology and trying to figure out what you actually want to do with it from a use case perspective, you need to figure out what kind of cloud infrastructure you're going to use, which virtualization platform, a packet core selection, RAN, what type of devices you're going to use, SIM allocations, so many different factors just to try to get a basic system up and running. And we at ASOCS wanted to make that experience as simple as possible. And towards that, we have developed this evaluation kit, which is basically a network in a box and includes all the ingredients and components, both from software and hardware point of view. So essentially, you can get started by deploying it quickly, connecting it to some basic applications, and then through your initial experience, you can branch out later to where you want to be at the end game.
Great, thank you. Another related question, and I want to mix things up and bring in Ashwin for this. Can I really run this on a cloud platform?
Yeah, absolutely. We can run on the cloud platform. It is cloud native technology. And the way we built it is make sure that when we build it once, and it should be able to run on public clouds, private clouds, and even on bare metal server. And it should be able to run at the hyperscale cloud environments or in the core of the network or the edge of the network or even on the premise. And we are ready for that. So running it on the cloud is actually a business choice rather than a technology choice right now.
That's perfect. And I believe we have time for one more question. And this is, I think, a wonderful question to close on. How do you view the role of the operator in this new 5G private network model? I think, Gilad, you wanna take a stab at that?
Yes, thank you. I do agree. It's an important question. Traditionally, operators tended to rely on two basic assumptions. One was that they own the spectrum in which they operate, and they were basically only competing with rival operators in a specific geography. And the second assumption they had is that their traditional telecom vendor would solve the problem for them. And both of these assumptions are not really relevant in this new era of 5G private networks, right? So while we do see a difference in the approach and attitude between operators who are operating in countries that have a coherent and viable spectrum strategy, whether it's the UK under Ofcom, Germany, Taiwan, Japan, and others, over carriers who are operating in countries which have not yet made those decisions or have made a decision to keep the traditional spectrum monopoly. So regardless of if you belong to the first group or the latter, you still need to realize that the rules of engagements have dramatically changed because enterprises, A, have other options, and B, they're expecting a complete different solution portfolio. So once an operator understands
these two new realities, he needs to try to figure out how does he integrate his traditional carrier software stack with the operation stack of an enterprise. B, how does he fit in his strategy with the new and very important role of cloud service and cloud edge providers, whether they would be Azure or AWS or any other? And three, how does he make his network scalable on one side, but also simple to integrate? So these are totally new challenges for an operator who was traditionally accustomed to deploy a network and then invite users to join in. In this case, he needs to bring to the table either a full solution by himself, which is not viable in the enterprise market, or figure out how to join in or interface with these enterprise networks as seamlessly and frictionless as possible. So, to make a long story short, basically, operators need to realize that they're going to need, this is the world of APIs, this is the world of new business models. And for them, their role will need to be to prove that there is merits for them joining the party. And one of the possible scenarios would be to show a coherent plan about how to integrate these silos of 5G private networks with their macro networks, primarily offering integrated services, farm to pan type of use cases, which would take time. So the role of carriers in 5G private network is still in a question mark on one side, but there is plenty of opportunity for operators to join in this party other than the spectrum angle, provided they understand the role in the ecosystem, understanding that they would need to welcome interfacing with cloud providers and with emerging software, independent emerging software providers such as ASOCS and others.
Well, I think that's a wonderful note to close on. I'm afraid that's all the time we have. Apologies if we weren't able to address your questions. I want to thank Albert, Ashwin, and Gilad for your insight on the topic of private 5G networks, and for the audience for tuning in and sending in your questions. So that ends our webinar. Thank you.